Let's slow it down and open this idea carefully, the way a physicist would, without rushing to conclusions. When people hear the sentence, aliens probably exist, they often imagine something dramatic, spaceships, strange creatures, or advanced beings watching us from the sky. But that is not what scientists mean. In physics and astronomy, the word alien usually means something far less exciting and far more reasonable. Life that formed somewhere other than Earth. The idea comes from chemistry, not imagination. Every atom in your body was formed in stars. Carbon, oxygen, nitrogen, these are not Earth-only ingredients. They are produced all over the universe. When we look at distant clouds of gas, we find the same chemical building blocks that exist here. When we study other stars, we find planets forming naturally around them. Planet formation is not rare or special. It is a normal outcome of physics. Now consider a simple thought experiment. Imagine baking cookies. If you bake one cookie in your kitchen, that might feel special. But if you bake billions of cookies in billions of ovens, it would be strange if only one cookie turned out edible. Earth is not a miracle oven. It is one kitchen in a universe filled with kitchens. This is why many scientists think life elsewhere is likely. Not guaranteed, not proven, but reasonable. However, notice something important. This argument only supports the idea that life might exist somewhere. It says nothing about intelligence. It says nothing about technology. And it definitely says nothing about visits. We tend to quietly jump from life exists to they can come here, but that jump is enormous. Life and travel are governed by very different rules. A bacterium living under the ice of a distant moon is life. A civilization capable of crossing interstellar space is something else entirely. Intelligence does not automatically lead to space exploration. Technology does not automatically lead to interstellar travel. These are human assumptions based on our own history, not universal laws. Even on Earth, life existed for billions of years before intelligence appeared. And intelligence existed for a long time before science. And science existed for a long time before rockets. Each step is rare, slow, and fragile. So when we say aliens probably exist, we are making a careful statement. We are not claiming visitors. We are not claiming messages. We are not claiming contact. We are simply acknowledging that the universe is large, old, and chemically generous. That idea alone is already profound. It tells us that life is not magic. It is chemistry given enough time and the right conditions. But it also reminds us of something humbling. Most life, if it exists, is likely simple, silent, and unimaginably far away. The mistake is not believing in aliens. The mistake is assuming the universe is built for meetings. Let's talk about the part that quietly destroys almost every alien visitation story: distance. Not dramatic distance, not the kind shown on a movie map, but real distance, the kind measured by light and time. The nearest star system to Earth, beyond our sun, is more than 4 light years away. That number sounds small until you remember what a light year actually means. It is the distance light travels in 1 year, moving at about 300,000 kilometers every second. Light is the fastest thing we know. Nothing with mass has ever been observed to move faster. So when we say 4 light years, we are saying that even the universe's speed limit needs more than 4 years to cross that gap. Now imagine building a spacecraft. Not a movie spacecraft, but a real one, made of matter subject to heat, stress, radiation, and energy limits. Suppose this spacecraft travels at 10% the speed of light, which is already far beyond anything humanity can currently achieve. At that speed, reaching the nearest star would take more than 40 years. That is 40 years in empty space, exposed to cosmic radiation, mechanical failure, and the slow decay of every physical system. And that is just the closest star. Most stars in our galaxy are hundreds, thousands, or even tens of thousands of light years away. Traveling to them would take longer than the entire history of human civilization. At that scale, travel stops being an engineering challenge and becomes a question of survival across generations. The travelers would need to outlive cultures, languages, and perhaps even their original purpose. This is where our intuition fails us. We are used to thinking in hours, days, or at most years. Our brains are not designed to handle distances where the journey itself is longer than recorded history. Science fiction compresses space so the story can move forward. Physics does not allow that courtesy. Some people argue that advanced civilizations might simply be better at traveling. But improvement does not erase limits. No matter how advanced you are, Energy must be paid to accelerate mass. No matter how intelligent you are, time still passes. No matter how long you live, the universe does not shrink. There is also no cosmic map with destinations marked interesting. Space is mostly empty. Stars are far apart. Planets are tiny targets orbiting tiny stars in vast darkness. Finding Earth from another star system is like throwing a dart across continents and hoping it lands on a moving grain of sand. Distance is not just a number. It is a barrier that shapes behavior. On Earth, distance limited ancient civilizations. Oceans delayed contact for centuries. Interstellar space is a barrier millions of times more severe. Once you fully absorb this, the idea of routine alien visits begins to feel less like a mystery and more like a misunderstanding. The universe is not refusing to send visitors. It is simply structured in a way that makes visiting extraordinarily unlikely. The silence is not suspicious. It is exactly what physics predicts when space is vast, time is long, and travel is brutally expensive. A common response to all of this is simple and confident. Maybe aliens are far more advanced than we are. Maybe they have technologies we cannot imagine. Maybe the rules that trap us do not trap them. At first glance, this sounds reasonable. After all, human technology today would look like magic to someone living 1,000 years ago. But physics is not impressed by intelligence. The laws of nature do not bend for advanced civilizations. They do not loosen their grip because a species has better mathematics or more powerful computers. No matter how intelligent a being is, it still lives inside the same universe made of the same particles, constrained by the same rules. One of the most popular ideas in science fiction is faster than light travel. The appeal is obvious. If you can move faster than light, distance stops being a problem. The universe suddenly feels small and friendly. But in real physics, faster than light motion is not just difficult. It creates deep problems. It breaks cause and effect. It allows effects to happen before their causes. Every serious theory we have collapses when this is allowed. So far, every experiment, every observation, and every successful theory agrees on one thing: light speed is not a technical limitation. It is a fundamental limit built into the structure of reality. Then, there are wormholes. On paper, certain equations allow shortcuts through space-time. But equations are not machines. To keep a wormhole open, you would need forms of matter or energy that may not exist in usable quantities. Even if they did exist, the wormhole would likely collapse faster than anything could pass through it. Physics sometimes permits strange possibilities, but permission does not equal practicality. This distinction matters. Many things are not forbidden by physics, but are still effectively impossible. You are not forbidden from stacking atoms one by one to build a mountain with tweezers. It is allowed. It is also meaningless in practice. Even near light speed travel, which is technically allowed, comes with severe consequences. Time dilation means that travelers age differently than those who stay behind. Enormous energy is required just to accelerate and even more to slow down. Collisions with tiny particles become deadly at such speeds. Space does not become safer just because you move through it faster. There is also an assumption hiding in these arguments that deserves questioning, that advanced civilizations would want to travel physically at all. Physical presence is expensive. Information is cheap. Signals, probes, and observations can cross space far more easily than bodies and cities. A civilization millions of years older than ours would likely understand this better than we do. It would not behave like explorers in an age of wooden ships. It would behave like something shaped by efficiency, not romance. The mistake is imagining intelligence as a ladder that eventually climbs out of physics. Intelligence does not grant escape. It only grants understanding. And the deeper the understanding, the clearer the limits become. Advanced aliens would not ignore these limits. They would respect them. And that respect alone may be enough to explain why no one ever shows up. To understand why interstellar travel is so unlikely, it helps to think less about technology and more about energy. Energy is the real currency of the universe. Every action, every motion, every machine must be paid for in energy, and the universe keeps very strict accounts. Imagine trying to throw a stone so hard that it never comes back down. You can throw harder, train longer, and build better tools, but eventually you reach a point where the effort required becomes enormous. To escape Earth's gravity, rockets must burn massive amounts of fuel just to lift themselves off the ground. Most of the rocket's weight is fuel used to carry more fuel. This already shows how unforgiving energy requirements can be. Now scale this problem up from Earth to the stars. To move any sizable object to a significant fraction of the speed of light requires an extraordinary amount of energy. The faster you go, the more energy you need, and this increase is not gentle. As you approach light speed, the energy requirement rises dramatically. It is not a matter of better engines. It is built into the mathematics of motion. At these speeds, energy demands become comparable to the total output of stars or entire planets. This is not the kind of energy you casually allocate for exploration. Even a highly advanced civilization would have to make serious choices about where its energy goes. Energy used for travel cannot be used for computation, survival, or stability at home. There is also the problem of carrying energy with you. Fuel has mass, and mass costs energy to move. This creates a feedback loop where more fuel requires more energy, which requires more fuel. Engineers have been fighting this problem since the first rocket was built, and it only becomes more severe as speeds increase. Then there are the dangers. At near light speeds, even tiny particles become lethal. A grain of dust, normally harmless, can strike with the energy of an explosive. Space is not empty enough to be safe at these velocities. Shielding against such impacts would require even more mass, which again demands more energy. Radiation adds another layer of difficulty. Outside a planet's magnetic field, travelers are exposed to high-energy particles that can damage electronics and biological tissue. Protecting against this radiation adds further weight and complexity, increasing the energy cost yet again. Energy problems do not stop at launch. Slowing down at the destination requires nearly as much energy as speeding up in the first place. You cannot simply arrive. You must decelerate, survive, and remain functional. All of this leads to a sobering conclusion. Interstellar travel is not just hard, it is inefficient. The energy cost per unit of information gained is enormous. From a purely physical perspective, it is one of the worst ways to learn about the universe. A civilization that understands energy deeply would likely see this clearly. Instead of sending themselves, they would send signals, small probes, or simply observe from afar. These methods achieve knowledge at a fraction of the cost. So when we imagine aliens choosing not to visit us, we should not think of fear or secrecy. We should think of budgeting. The universe rewards efficiency, and interstellar travel is a terrible bargain. Even if distance and energy were somehow manageable, there is another barrier that is far more subtle and far more ruthless: time. Time does not behave the way our instincts expect it to, especially when stretched across cosmic scales. Human history feels long to us. Thousands of years seem immense. But in cosmic terms, human civilization is a brief flicker. Modern technology has existed for only a tiny fraction of that time. Radio communication, which could announce our presence to the galaxy, has been around for barely a century. Space travel even less. This means that Earth has been visible as a technological civilization for an extremely short window. Before that, there was nothing to detect except natural processes. After that, there is no guarantee how long this window will remain open. Now imagine another civilization somewhere in the galaxy. It might have risen millions of years ago and vanished long before humans ever looked up at the stars. Or it might emerge millions of years from now, long after Earth is quiet. The universe is old. Civilizations may be brief. For two civilizations to meet, an extraordinary alignment must occur. They must exist at the same time. They must develop technology capable of communication or travel. They must decide to use it. And they must survive long enough for signals or travelers to arrive. Each of these conditions reduces the chances dramatically. This is not speculation. On Earth, most species that have ever existed are extinct. Stability is rare. Continuity is fragile. There is no reason to assume intelligent life elsewhere is exempt from this pattern. Time also stretches journeys in cruel ways. A voyage lasting thousands of years may be trivial on a galactic timeline, but it is devastating on a cultural one. Languages evolve. Goals changed. Knowledge is lost and reinterpreted. A mission launched for one reason may arrive in a universe where that reason no longer makes sense. Even biological survival becomes questionable. Generational shifts are not just engineering challenges, they are social experiments with no precedent. Maintaining purpose, cooperation, and meaning over centuries is not something physics can solve for you. There is also the problem of time dilation. At very high speeds, travelers experience time differently from those left behind. While this might shorten the journey for those on board, it does nothing to help coordination or communication with the civilization they left. By the time they arrive, everything at home may have changed beyond recognition. All of this reveals something important. The universe does not just separate civilizations by space. It separates them by time. These separations compound. They stack. They erase overlap. So when we ask why no one has arrived, we may be asking the wrong question. The more honest question is whether meetings are even compatible with the way time works in a universe this old and this large. Silence, in this light, is not a mystery. It is what happens when brief sparks of intelligence appear at different moments in an endless cosmic night, too early or too late to ever see one another. There is a famous question often summarized as, "Where is everybody?" It sounds simple, almost playful, but behind it lies a deep misunderstanding about how the universe works. The question assumes that if intelligent life exists elsewhere, evidence of it should be obvious. Ships should arrive. Signals should fill the sky. The absence of these things feels like a puzzle. But puzzles only exist when expectations are justified. The expectation of contact comes from a very human way of thinking. On Earth, when civilizations become technologically capable, they expand, they explore, they trade, they collide. History teaches us that isolation tends to shrink as technology improves. It feels natural to project this pattern onto the universe. Physics does not agree. The universe is not an extension of Earth scaled up. It is a fundamentally different environment. Distances are not just larger. They are categorically beyond what intuition can manage. Energy costs are not just higher. They rise to levels that reshape priorities. Time does not gently stretch. It fractures continuity. When these factors are taken seriously, the absence of visitors stops being surprising. In fact, it becomes expected. Consider communication. Even signals move at light speed, and light speed is slow when galaxies are involved. A message sent across the galaxy can take tens of thousands of years to arrive. A reply takes just as long. Conversations become impossible. What remains are echoes, not dialogues. Then consider expansion. The idea that advanced civilizations inevitably spread across the galaxy assumes a desire to colonize and the ability to sustain such expansion indefinitely. Neither assumption is supported by physics. Expansion multiplies energy demands, risk, and instability. Growth without bound is not a physical law. It is a biological habit, and biology does not scale well to cosmic distances. There is also a quieter possibility civilizations may be common, but detection is hard. Technology does not necessarily announce itself loudly. Efficiency often means reducing waste, not broadcasting energy into space. A mature civilization may leave very little trace, blending into the cosmic background rather than lighting it up. Question: where is everybody? Treat silence as evidence of absence. But silence can also be evidence of constraint. It can be the natural outcome of a universe where distance, energy, and time punish interaction. Once you accept this, the question transforms. Instead of asking why aliens are not here, you begin to ask why you ever expected them to be. The expectation itself becomes the mystery. The universe may be full of life and still feel empty. These two ideas are not opposites. They are compatible outcomes of the same physical laws. A crowded universe does not have to be a connected one. What we call a paradox may simply be our refusal to let go of Earth-based intuitions. When those intuitions are set aside, the silence stops demanding an explanation. It becomes the most reasonable outcome we could have predicted from the start. The difficulty in accepting all of this does not come from a lack of information. It comes from the way the human mind is built. Our brains did not evolve to understand galaxies, light years, or cosmic time. They evolved to help us survive in small groups, over short distances, within immediate surroundings. When we try to imagine the universe, we are using tools that were never designed for the job. We are comfortable with distances we can walk, drive, or fly. Even when we talk about traveling around the Earth, our intuition still works reasonably well. But the moment we move beyond the solar system, intuition collapses. Numbers lose meaning. Words like far stop being useful. The universe becomes abstract, and abstraction is where the human mind struggles most. Science fiction fills this gap. It reshapes the universe into something emotionally manageable, and planets are close together. Travel is fast. Encounters are frequent. These stories feel believable not because they are realistic, but because they align with how our minds expect the world to work. They scale the cosmos down to human proportions. Physics does the opposite. It forces us to accept a universe that is indifferent to our expectations. Space is not organized around convenience. Time does not speed up because we are impatient. Distance does not shrink because we are curious. The universe does not adjust itself to fit the limits of human storytelling. Another source of confusion is the way we think about intelligence. We often imagine intelligence as a straight line that leads inevitably toward expansion, exploration, and contact. But intelligence is not a single trait. It is a collection of adaptations shaped by environment and necessity. What seems like a natural goal to us may be irrelevant or even undesirable elsewhere. Even on Earth, intelligence expresses itself in wildly different ways. Humans explore physically because our environment allows it and our history encourages it. That does not mean this behavior is universal. Assuming otherwise is a projection of our own psychology onto the cosmos. There is also a deep emotional component at work. The idea of being visited appeals to a desire for significance. Contact would feel like confirmation that we matter on a cosmic stage. Silence can feel like rejection, even though the universe is incapable of rejecting anyone. But physics does not operate on meaning. It operates on rules. When those rules are applied consistently, the absence of contact stops feeling personal. It becomes mechanical. The human struggle then is not with the idea that aliens might never come here. The struggle is with accepting a universe that is vast, quiet, and unconcerned with our presence. We want the universe to notice us. Physics suggests that noticing is not part of the design. Understanding this requires humility. Not the dramatic kind, but a quiet one. The kind that accepts that reality does not owe us encounters, explanations, or visitors. Once this is understood, the silence of the universe stops being eerie. It becomes a natural consequence of scale. And in that understanding, there is a strange kind of clarity. If you follow all of this carefully, something subtle begins to change. The question is no longer about aliens. It is about how we relate to reality itself. We start by asking why no one has come to visit us, and we end by realizing that the universe was never designed for visits at all. The universe is not a stage built for meetings. It is not a network waiting to be connected. It is a physical system governed by rules that do not care about curiosity, loneliness, or wonder. Stars form because gravity allows them to. Life may arise because chemistry makes it possible. Intelligence may emerge because complexity sometimes crosses a threshold. But none of this implies closeness, coordination, or contact. What changes perspective is recognizing that rarity and isolation do not reduce meaning. They create it. A universe where everything is easily reachable would be smaller, not larger. A universe where contact is guaranteed would be simpler, not deeper. The vast separations are not flaws in the design. They are the design. From this viewpoint, Earth stops being a waiting room for visitors and becomes something far more interesting. It becomes a rare island where matter has learned to think. Not because it was chosen, but because it happened. Not because the universe wanted witnesses, but because the laws of physics allowed complexity to climb high enough to ask questions. The absence of alien visitors does not make the universe empty. It makes it honest. It tells us that existence does not revolve around connection. It revolves around possibility. Most possibilities never meet. They simply exist, briefly, independently, and then fade. There is also a humbling realization here. If no one is coming, then there is no one to impress, no cosmic audience. No external validation waiting beyond the stars. Meaning does not arrive from outside. It emerges locally, in small pockets of space and time where awareness appears. Physics does not tell us what to feel about this. It only tells us what is likely. And what is likely is a universe filled with silent distances, scattered light, and long stretches of darkness between brief sparks of understanding. Seen this way, the real miracle is not that aliens have not arrived. The miracle is that we are here now, at this moment, capable of understanding even a fraction of what surrounds us. The atoms in your brain obey the same laws as distant galaxies, yet they have arranged themselves into a structure that can wonder about galaxies at all. That is not a setup for disappointment. It is a quiet invitation to maturity. The universe is not obligated to be dramatic. It is allowed to be vast, slow, and indifferent. Our role is not to demand visitors, but to notice where we already are, on a small planet orbiting an ordinary star, in a universe that does not explain itself, we have learned enough physics to realize why the silence makes sense. And once that understanding settles in, the silence stops feeling empty. It starts to feel accurate.